A little note taken today. It's already Thursday, so we're almost through the week. Today, believe it or not, we are going to talk again about fractions. So while I'm prepping here, if you would grab some of your notes under fractions, or if you want to start a whole new piece, that would be either one would just be absolutely fine. Fractions make the world go round. I wonder who the guy was that invented those fractions, but here we go. So on top, if you don't already have it, we are talking about fractions. And the little subheading under fractions here is going to be renaming them, which means giving different names for them. Because if you think about this here, let me throw this at you here. One of the things we talked about that makes fractions a little confusing is there's a whole bunch of different ways that you can say fractions. For example, let's go back to our old pizza pie thing here. You know, if you cut a pizza in half, you can eat half of it like this. But pretty rarely are pizzas just cut in half. You know, I guess maybe you could have a pizza that was cut into 4 pieces, but you could still eat 1/2 by eating 2 of the 4 pieces. So those fractions mean the same thing, but we use different numbers for them. And we could go on forever with this. Maybe our pizza is cut into 6ths. I'm not very good at cutting into 6, and to eat half of it, you would eat 3 of the 6 pieces. Or maybe our pizza, which more likely is cut into 8 pieces, and then you would eat 4 of them. Okay, and the thing, like I said, that makes this all kind of confusing is all of these fractions mean the same thing. Now, usually we always want to use the smallest one, but there are times when we need to rename fractions and actually move them and make them bigger to different numbers. Okay, and that's based on this one simple principle that you've done absolutely forever. And that is the multiplying by 1 principle. For example, you remember this property of math. You take 6 times 1, you're going to get 6. Or if you take 25 times 1, you're going to get 6. Well, same thing is true for fractions. If you take 1/2 and multiply it by 1, you're going to get 1/2. To which you're going to say, so what? How does that even make any sense to what we're trying to do here? Well, here's the deal. Let's just take a short, small break here. If we look at the number 1, we have talked about before that there are countless and endless fractions that are the same thing as 1. For example, 1/1 is 1. 2/2 is 1. 3/3 is 1. And so on, and so on, and oops, sorry. And there I just made 4 out of 5. Oop, 4/4 is 1. And 5/5 is 1. I'm going to move this thing over here. Okay, so all these are equal to 1, which means, going back to this, I hate to keep flip-flopping here. If I start with my 1/2, and I multiply it by a fraction that is the same as 1. Right, I'm going to erase that because I just don't like how that looks. Bear with me. Here we go. I'm going to start with 1, or 1/2. If I start with 1/2, and I multiply it by a fraction that is the same as 1. Let's say I pick 4/4. I end up with 1 times 4 is 4, and 2 times 4 is 8. I end up with 4/8. And because I multiplied by the fraction by 1, I didn't change how much the fraction stands for. 4/8 is the same as 1/2. They're equal because I multiplied it simply by this 1. And you will see the book will do this for you, so don't get confused when they do this. A lot of times, to prove this point to you or show this point to you, they will make the outline of a number 1 right here, so that you have to draw, oops, so that you, oh boy, so that you, I know you're laughing at me right now, so that you can see that what we're really doing is not changing it, we're just multiplying by something that is the same as 1. So let's do a couple more just for fun here. Let's see. You know, I could start with the fraction 2/3 and multiply it by something that is the same as 1. Here, I'll draw the little 1 like they do in the book. I have a hard time going up. And let's just say I pick 5/5. Because 5/5 is the same as 1, the fraction I get over here is going to be the same as 2/3. It's just going to be using different numbers. So 2 times 5 is 10. And 3 times 5 is 15. 10/15 is the same as 2/3. Really what we're doing there, kids, okay, remember before we talked about having to reduce? Before we were starting with 10/15 and moving it down to 2/3. Now we're kind of going the other way. Now a couple different things that are going to happen with this will be this. Let's say I have the fraction 3/4 and I want to know what new fraction I could make with 3/4 that has a 20 on the bottom. Okay, what new fraction that equals 3/4 has a 20 in its denominator? And this is what you need to think about. Okay, first of all, we're thinking about what fraction can I multiply 3/4 by that is the same as 1 that would give me a 20 on the bottom. And you just need to think about this. 4 times what number gives me 20? And hopefully you know that's a 5. And the deal is, in order for this fraction that you're multiplying by to be 1, whatever is on the bottom must also be on the top. So if you multiplied 4 by 5 to get 20, you have to multiply 3 by 5 to get the appropriate right number on top, which would be 15. 15/20 is the same as 3/4. Okay, now when they give you this problem from the book, please, please, please circle this number that you're missing, because that will be the number I read. I will not read that entire thing if we're looking for that. Let's do a couple more examples. What if it was 7/8 and I said I want to make an equal fraction with this one? This time let's do the top. Let's say I wanted a 21 on the top, and what number would go on the bottom? Again, the only thing you need to think about here is start with what you know. How do I go from 7 to 21? What do I multiply by? I multiply by 3. Whatever I multiply the top by, I need to multiply the bottom by. And 8 times 3 is 24. And there is my answer to that. Another one, how about how about 5/8? 5/8 equals what number over 32? Again, it's pretty simple. You just, and again, you need to know your multiplication pretty well here. 8 times what is 32? That's 8 times 4. 5 times same number on top. 5 times 4 is 20. And boom, you're good there. Now you're ready for the most complicated one? This is a problem that so many people have questions on, but I think you guys will be able to get it. Write this problem down. This is exactly an example right out of the book. So here's my example. The book will tell you to do this. Write 1/2 and 1/3. Write 1/2 and 1/3. Write 1/2 and 1/3 with denominators of 6. With denominators of 6. Then add the two new fractions. Then add the two new fractions. Okay, and what they're doing here is they're showing you how, remember, if you go back to when we added fractions together, we said that we needed to make the bottom numbers the same. Well, that's what this is. And it's not so bad if you take it step by step. If you look at it, it gets kind of confusing if you read it all as one big group. But if you take it step by step, it said to write, let's do this first, write 1/2 and 1/3 with denominators of 6. That means this. All right, we've already just been doing this. I take 1/2 and I want to change it so that its denominator is 6. And I want to do the same thing with 1/3. I want to write 1/3 so that it has a denominator of 6. And I would suggest that since we're adding, let's write them up and down like it says in our notes. And here's what it looks like. Okay, you have to say to yourself, well, to go from 2 to 6, I multiply by 3. So to go from 1, I have to multiply it by 3 as well for my new top number. 1/2 equals 3/6, which makes sense. Same thing on the bottom. 3 times what is 6? 3 times 2. So 1 times 2 is 2. So my new fraction there is 2/6. So that was step number 1. Then, now because they do have the same bottom numbers, I can actually add these fractions, 3/6 and 2/6. Well, if you look at your notes, when you add fractions, the bottom stays the same, and you add or subtract the top. 3 plus 2 is 5/6. And all those words, all that gobbledygook just ended up being 5/6. So hopefully 6th grade, that was a big help for you. It takes a little time to get used to some of this, but you guys can do it. So thank you so much for listening. We'll